There's something that's just deeply unsettling about the idea of the sun disappearing in the middle of the day. It really goes against every natural rhythm we know. For thousands of years, this very event has been a source of awe, of fear, and of myth. So today, let's explore the powerful forces that can literally turn day into night. I mean, really think about it. You're just going about your day, and suddenly the light just fades away. And this isn't just some sci-fi scenario. It's a real phenomenon, and it has a whole host of incredible and sometimes kind of terrifying explanations. It really taps into this primal fear of a world just being turned completely upside down. And this quote right here, it just nails why this is so much more than a weird weather event. That sudden loss of daylight, it just feels wrong, like a break in the cosmic order. So it's really no wonder that ancient cultures saw it as a message from the heavens, a sign that the very balance of the universe was at stake. But behind all those myths and ancient fears, there's this whole tapestry of powerful, natural, and, as we're about to see, human-made forces. So we're going to break down exactly what causes these dramatic midday blackouts. First up, let's talk about the colossal forces of nature itself. I'm talking about the geological and celestial events that are so immense, they can simply blot out the sun from our view. So the most predictable, but still absolutely breathtaking cause of midday darkness is a total solar eclipse. This is just celestial clockwork in action. It's when the moon passes directly in front of the sun, casting this fleeting shadow right across the Earth. And that alignment has to be absolutely perfect. The moon's shadow then races across the surface of the planet, plunging this narrow path into darkness. But it's the quality of the light that makes it so unique. It's not a hazy dimming, it's a sudden, crisp removal of sunlight. It creates this eerie, silent twilight that feels completely different from any other kind of darkness. Okay, now for something way more chaotic. Volcanic eruptions. These are the historical champions of dimming the atmosphere. A single explosive eruption can darken skies over huge areas, not for a few minutes, but for days or even weeks. It's the sheer volume of material that gets thrown into the atmosphere that makes all the difference. I mean, after the 1815 eruption of Mount Tambora, the ash cloud was so thick that people actually needed lanterns at noon. But the effect went global. So much sunlight was blocked that 1816 became known as the year without a summer, causing massive crop failures and famine all across the northern hemisphere. From fire to earth, our next cause is the dust storm. In really dry regions, these immense walls of dust and sand, sometimes they're called haboobs, can rise for miles into the air and just roll across the landscape, completely engulfing entire cities in this thick brown-black cloud. And you can really see the difference in what that feels like here. An eclipse, like we said, gives you that sharp, defined shadow. A dust storm, though? Whoa, that's a completely different beast. It's this suffocating, rolling wall that gradually collapses day into a thick, murky night. The black blizzards of the 1930s Dust Bowl were famous for this, literally turning midday into total darkness. All right, let's dive into our next set of causes, which range from these massive fires to, well, even threats from outer space. More and more, we're seeing midday darkness caused by massive wildfires. These infernos release such enormous amounts of smoke, soot, and carbon into the sky that they can create this thick, dark canopy over thousands of square miles. The experience of being under one of these smoke plumes is just surreal. As we've seen in recent fires in Australia and California, the sky doesn't just go dark, it turns this bizarre apocalyptic orange. The sun becomes this tiny red ember, or sometimes it just vanishes completely, and the air gets thick and strangely silent. Okay, this one is pretty wild, and thankfully very rare. Biological blackouts. Get this. Back in 1875, a swarm of Rocky Mountain locusts in the American West was estimated to be 1,800 miles long and contain trillions of insects. Eyewitnesses said the swarm was so dense, it literally blotted out the midday sun for hours as it passed over. And now for the most catastrophic, though thankfully the rarest cause. A large meteor impact would blast so much pulverized rock and dust into the atmosphere that it could block sunlight on a global scale. It would create what's called an impact winter that could last for years, pretty much exactly what happened to end the age of the dinosaurs. Okay, so we've looked at all these incredible causes, but how do they actually work? Well, the core science behind all of them is something called light interference. Really, it's all about tiny particles in the air just getting in the way of sunlight.
The physics here are actually pretty simple. It really just comes down to two main things. First, you've got scattering, where sunlight basically bounces off these particles in all different directions. And second is absorption, where the particles just soak up the light's energy. The bottom line is, the more particles you have in the air, whether it's ash or soot or dust, the more light gets blocked and the darker it gets on the ground.
So far, we've pretty much just looked at nature's awesome power. But we can't ignore the times when the darkness wasn't caused by volcanoes or meteors, but by us. Back during the height of the Industrial Revolution, cities like London were choked with so much coal smoke that they had these black fogs thick enough to block out the sun. And don't think this is just something out of a history book. Severe air pollution events in megacities around the world still cause these day-for-night scenarios today. The most infamous example of this has to be London's Great Smog of 1952. For 5 days, this blanket of toxic, coal-fueled pollution was trapped by the weather, and it just plunged the city into darkness. Imagine this. At noon, it was so dark that people needed flashlights just to walk down the street. It was a terrifying, completely human-made night. So all of this brings us to a really critical question. What does this mean for our future? How do all these different phenomena connect to the world we're living in right now? And here it is, the key takeaway for our modern world. Scientists expect that as our climate changes, some of these events are going to become more common. Things like altered jet stream patterns and rising temperatures create hotter, drier conditions that fuel these megafires, while expanding deserts mean more potential for massive, sky-darkening dust storms. This quote right here just sums it all up perfectly. We take that blue sky for granted, right? But it's not some permanent fixture. It's this thin, fragile, and dynamic shield. And, well, whether it's through natural forces or our own actions, it can be disturbed. The light can be switched off. So that's the thought we end on. Midday darkness is no longer just a subject of myth or history. It's a real and potentially growing feature of our changing world, which forces us to ask, just how stable is that blue sky we all depend on?